Hello everyone. I hope that you can hear me. Can anyone confirm if you can hear me? Oh, happy to have the chance to meet you again, have a stream with you. So, I hope everything goes well. How was the contest today? I'm good, almost good. There was some issues in my personal life, but yeah, I think they are getting resolved now. But yeah, I was too busy in the recent days, and yeah, I had some serious problems. Okay, okay. So mostly till C and D. Okay. Okay, let me start. Should I start now or should I wait a little bit more? Okay, I think. Okay, it seems that everyone are ready for starting the stream. So, I see. So, most of you have solved till C, some of you till D. Has anyone solved E? I want to see what is our potential today. Has anyone solved E? Or F? I've read problem B, and I don't think it's just about having two types of numbers. I don't think so. I don't think it's only that. So maybe we should start now. Uh, Let me just fix something. Change the start time because we're gonna be awaited a bit more. So none of you have solved E, right? Solved E, but got time limit exceeded in test 2. Has anyone get accept from that problem? Get accepted? We'll wait 2 more minutes, for example, for the others to join. Okay. No, not B. I'm saying E. The fifth problem. Not problem B. Oh, awesome. You reached pupil. Awesome. Congrats. That's really good. I personally, when I got back to pupil, I was really happy because it was so, it was so hard at that moment. I was also a newbie, and when I got to pupil, I felt good, really. Okay. Okay, guys. So maybe we should start now. Well, let's talk about the first problem here. Uh, about the first problem, it says that Alice and Bob have bought a ribbon consisting of n parts, and now they want to paint it. First, Alice will paint every part of the ribbon into one of m colors. For each part, she can choose its color arbitrarily. Then Bob will choose at most k parts of the ribbon and repaints them into the same color. He chooses the affected parts and the color arbitrarily. Bob would like all parts to have the same color, however, Alice thinks that this is too dull, so she wants to paint the ribbon in such a way that Bob cannot make all parts have the same color. Is it possible to paint in such a way or not? Well, this problem is the first problem and the easiest one. Well, do you all agree that we should have at most n minus k minus 1 of each numbers, right? I mean, you cannot have more than n minus k minus 1 numbers, because if you have, if for some color you have at least n minus k of them, then you can change the rest of them, the rest of the cells, because they are at most k, and all of them will be in the same color. So each color can have at most n minus k minus 1 occurrences. So we should multiply this by the number of different colors. So we have m times n minus k minus 1. This value should be at least n. I mean, it should be enough. I mean, if from each color we can have at most these many occurrences, this is good, because no color can dominate all the colors, and we can color the rest of the cells so that everything will have the same color. All of them are at most n minus k minus 1, so you need at least to change k plus 1 cells, right? Therefore, here you are sure that nothing will cause a problem. So if m times n minus k minus 1 was greater than or equal to n, the answer is yes, otherwise the answer is no. Okay? And you can see it here. For example, in this case, 5, 2, 1. We have two colors, and from each color we can have at most 3 occurrences. 5 minus k is equal to 1 minus 1. From each of them we need to have at most 3 of them, right? We can have at most 3 occurrences of each color, because if we have more than 3, then if we have 4, it means that we can make all of the colors the same by changing the other one, the one remaining one. So we can have at most 3, and because 2 times 3 is greater than or equal to 5, then it is okay, and the answer is yes. In this example, 5, 2, 2, we should have 2 times 5 minus 2 minus 1, because this time each color should be used at most twice, not 3. At most twice, not 3 times. Because if one of them will occur 3 times, then you can change the rest of them to other one of them, and all of them will be from the same color. And this is not greater than or equal to 5, it is less than 5, so the answer is no. Does the first problem make sense? If you are okay with the first one, we can move on to problem B. If anyone has any question from problem A, I will discuss it further. Otherwise, I will move on to problem B. Let me bring chats in my phone too. Okay. Oh, camera is blocking my raising. Okay, never mind. I was just writing that 2 times 5 minus 2 minus 1 is less than 5. Okay. So this one is a no. Because m times n minus k minus 1 is less than 5. Okay, awesome. In this problem, we don't need any sailing, etc. Of course, there are some different approaches as well. Maybe another approach uses that. But you don't even need that too. You know that for each color, you will have at most these many of them, and this should cover all the cells. And they should be at least n. Okay, so let's move on to the second problem, problem B. Make it ugly. It says that let's call an array A beautiful if you can make all its elements the same by using the following operation an arbitrary number of times, possibly 0. Choose an index I such that A of I minus 1 is equal to A of I plus 1 and replace A of I with A of I minus 1. You are given a beautiful array A1, A2, 2, AN. What is the minimum number of elements you have to remove from it in order for it to stop being beautiful? Swapping elements is prohibited. If it is impossible to do so then output minus 1. The first question, guys, when the answer is minus 1, can anyone say that? When the answer is gonna be minus 1. I think it's good to know your opinion. Yeah, many of you said that if all of the elements are the same, then obviously you can't do anything, right? Obviously, as many as you remove, still all of the remaining elements are equal, and you can't do anything. But if you have two different type of numbers, for example, you have one A and one B at least. Worst case scenario, you can remove all the other elements. In the worst case scenario, you can remove all the other elements, and then you have an array that is not beautiful. Okay, so the answer is minus 1 if and only if all the elements are the same. If you have two different numbers, you can use those two. Just remove everything else. In the worst case scenario, we always have this solution. If we didn't have a better solution, we can just remove everything else, and our array is not beautiful anymore, right? So this is the first thing that we can say in here. Now, when we want to find out that how we find the minimum number of elements that we remove, well, the first thing that I think of is the possibilities that makes, what should happen so that the array is not beautiful anymore. Okay, that's the first thing that comes to my mind. That's what are the things that should happen. For example, assume that we have 3 elements which are all distinct right after each other. Let me write it like this: x, y, z, and x, y, and z are all different. Then what can I say if I have 3 consecutive non-equal elements? Yeah, one of you said a very nice one that I will talk about. Yeah. Why it is already ugly? If we have 3 distinct elements, 3 distinct consecutive elements. Yeah, I'm not talking about a test case. I'm saying if an array has 3 elements that they are not the same, then it means that, yeah, then it means that the array is ugly now. It's not beautiful anymore. So if you have 3 elements which are distinct, it means that they are all if they are all different, it means that the array is ugly. And also, because the array is beautiful, the first and the last element should be the same, as you said. Because if they are not the same, you know, one thing that you can always say is that the first element and the last element never change. I mean, there's no way to change the last elements, and there's no way to change the first elements. So they are always going to be the same as they are right now. So there's nothing that you can do. Uh, yes, yes, yeah, I know. Yes, if we have x, y, y, we can't fix these parts, but it's possible that we have another y in here that we change these three and we change this one to y. So still, it might be beautiful. But what I'm arguing is that if we have x, y, z, we have three consecutive elements that they are x, y, z, then there's no way that I can fix this array. I mean, there's nothing that I can do. Okay. I'm just talking about different facts that we have. You can also tell your solutions as well. I mean, that's okay. It's okay to have different solutions. Maybe you have simpler things to say, right? Let me see. The indices of elements which are not equal to a0 and find the shortest subsegment. Length of continuous subarray of shortest repetition of a0. Let me see, what do you mean? You start from a0, you mean you want to remove the minimum number of elements. So I guess you mean you want to keep the longest subsegment consisting of a0, right? Because a0 is equal to a of n minus 1, find the closest element from the left or right which is different from a0. Yeah, that seems reasonable too. So yeah, the approach that most of you have solved and you're mentioning is that it is going to be simpler if we look at it like this. We have a0 and a of n minus 1 in here, and because these two should be equal. So the point is we want to do something that one of the elements in here, we want to do something that this would be, you know, at one side of the answer. I mean, we want to remove a prefix such that these elements would be the first elements of the final array, or find the rightmost one that we can remove a suffix after that such that this part will be left, right? Yeah. Yeah, that would work as well. But I think for me it wasn't straightforward to think this way about it. I mean, when I read this problem, I started to think with my own approach. But this I find this one reasonable too, because you know the whole thing behind it is that we have to do something. Oh, let me see. The minimum. Try to add another 3. Okay. So you still say that you will remove these 3 threes and okay. So yeah, what everyone are trying to say here is that we have several a0s at the beginning and several a0s at the end, right? And everything should turn equal to a0 definitely, because if everything is gonna be equal, all of them should be equal to a0, right? Yeah. Yeah, I see. I see. Yeah, I see. So yeah, so what we can say, yes. So we have several, I think we have several blocks in here. And between each two blocks, there are several a0s, right? I mean that these are the elements which are not equal to a0. And these are the intervals consisting of a0. I think that also if we remove these subsegments, still the answer wouldn't work, right? I mean, the sequence is gonna be ugly. Right? So yes, so we have to find the minimum block. Yeah, I was trying to reach here as well, but yeah, I thought that your approach is gonna end up simpler than this. Yes, so at the end you are gonna say that we have several blocks of a0s, and between them there are some elements which are not equal to a0. And you are gonna remove the minimum continuous subsegment consisting only of a0. Because if you do that, either the first or last element is not gonna be a0 and the other one will be a0, or there are two different elements right after each other. There are two elements, and it's okay if there are any values. They can also be equal. If they are these two elements and you make them adjacent, even if x is equal to y, then there's no way that we can make both of them a0. There's no way, because each one of them need the other one to become a0 first, right? If we have some x and y right after each other, and this is a0, the first one is a0 and the last one is also a0, then we have to, if this happens, we have no way to make both of them a0, because if y is gonna become a0, it needs x to be a0 first. If x is gonna be a0, it needs y to be a0 first. So none of them can become equal to a0, right? So the whole point is that we want to either make two of non-a0 values adjacent, or remove the or make one of the first elements and the last elements equal to something not equal to a0, right? So this is the whole thing that we're going to do. So the whole thing is that we find the maximum size of a continuous parts, all of them consisting of a0, and trying to remove them. For example, if we run this on test cases, let me go back here. In here we have 2, 2, 2, all of them are the same, so we can do nothing. In here, a0 is equal to 1. We have several occurrences of a0. The minimum size of a block is 1 as well. We have 3 blocks of size 1, so the minimum is 1. The answer is going to be 1. In this one, in the last test case, we have a blocks of 3 a0s here and a block of 3 a0s in here. So the minimum of them is still 3. So it's gonna be 3. Okay. So we are gonna find all the subsegments all consisted of the same number, and we try to output the minimum value among them. Does this make sense? Is problem B completely okay? Discuss problem A again. I can discuss problem A again at the end of the stream if you want, but I think because there are some people waiting for the next problems, I think it's better that for now we move on to the next problem. If you have any question about problem B, you might ask now. Otherwise, I'll move on to the next problem. So the whole point about problem B was that we try to find all the subsegments consisting of value A0 and among them we are gonna print the one with the minimum length. Okay, so if you're okay, we will move on to problem C. I haven't read this one. You are given two integers x and y of the same length consisting of digits. I have planned to think on this with you, I mean in front of you. You are given two integers x and y of the same length consisting of digits from 1 to 9. You can perform the following operation any number of times, possibly 0. Swap the ith digit and in x and the ith digit in y. Okay. For example, if x is equal to 73 and y is equal to 31, you can swap the second digits and get 71 and 33. Your task is to maximize the product of x and y using the aforementioned operation any number of times. If there are multiple answers, print any of them. So we want to maximize the product of x and y. Well, an important thing, the first thing that comes to my mind is that the sum of these numbers remains the same. Okay? So the sum always remains the same. When your two numbers, you're just swapping digits. For example, this always worth 1, this always worth 3, this always worth 70 because it is 7 at the second position. It always worth 70. And this always worth 30. And it doesn't matter in which of the numbers they are. It's just about, it doesn't matter in which one they are. And it's just, we can say that because it's just about the digits and their positions, the sum is going to be always the same. This is the first thing that comes to my mind when I read such problem. So when the sum is fixed, the product is going to be maximized. When sum is fixed, the product is going to be maximized if the numbers are closer to each other as much as possible, right? Do you agree? If you want, I can also tell you the proof of this. But anyways, when sum of two numbers are equal, then their product is maximized when these two numbers are close as possible with to each other, right? Yeah, sure. Assume that I want to give you a proof like this. Let me. Just I want to give you a visual proof. Assume that we have a class of, for example, n students. Okay. And we want to have them into two groups of like x and y. Obviously, x plus y should be equal to n because we have n students in total. Such that each person from each group hates all the people from the other group. So each person from this group hates all the people from this group and vice versa. Right? So for each two people, one of them from the first group, one of them from the second group, they will hate each other. Right? So how many pairs do we have that they hate each other? So we have a class of n students, and from each person from the first class, from the we have them into two groups. Each pair of people, one of them from the first group and one of them from the second group, they hate each other. So how many pairs do we have such that they hate each other? Can anyone say that? Exactly, x times y. Because for each person from the first group, he he is paired with everyone from the second group. So we have x, y people. You know, for each of these x people, we have y people. So we have x, y. Okay? So now assume that we want to maximize the number of pairs that they hate each other. Does this make sense if one of the groups, you know, for example, this x is less than or equal to y minus 2? I mean, does it make sense that if one of the groups has less than the other group, has less people than the other group, and their difference is at least 2? Does this make sense? If we want to maximize the number of pairs that they hate each other. Well, assume that x is small. Okay, let me write it like this. Let me draw it like this. Assume that x is small compared to y. X is less than or equal to y minus 2. The point is, if you want to maximize the number of people who hate each other, maximize the number of pairs that hate each other, if this happens, if x is less than or equal to y minus 2, we can just move one of people from this group to this group, and then he will not hate these people, but so these pairs will be removed, but instead these pairs will be made. So he will not hate the elements in the people in the other group anymore, but instead he will hate all the people in this group. And we know that it is more than that, because he's not gonna hate x people anymore, but instead he's gonna hate y minus 1 people. And since x is less than y minus 1, this is a positive number. So we increase the number of pairs who hate each other. Okay? I'm just trying to give you something that gives you intuition. That's why it makes sense. Right? I'm saying that if you have, I mean, if we want to maximize the controversy, we have to make these two groups, the size of the two groups, as equal as possible. Then we have the maximum controversy. And why? Because if one of them is way smaller than the other one, we can just move one of the people from here to that group, and then the controversy will be increased, because this person will not hate these x people anymore, but instead he will hate all these y minus 1 people. Right? And you know, first I'm just trying to give you some intuition. I mean, some intuition behind it. Then I will also tell you the algebraic proof. But first I'm just talking about this intuition. So we have x students here, y students here. The sum of x and y is equal to n. I'm saying that if we want to maximize controversy, it doesn't make sense if x is less than y minus 2. It's definitely not maximum. Because we can move one of people from this large group to that small group, and he will not hate people in that small group anymore, but instead he will hate all the people from the bigger group. Right? Yes. So if x and y are closer, then the the amount of the number of pairs who hate each other will be maximized. I mean, if they are as close and as possible. I said that there are n students. We have them into two groups. For example, these are the fans of, for example, I give you a football reference, Real Madrid. These students are the fans of Barcelona. Okay? So these people hate each other. Now we want to see that in which situation the number of pairs who hate each other will be maximized. Right? I'm saying that if from the group with more people, if their difference is greater than 1, if the difference of people is greater than 1, if we move one person from this, if some person we assume that he was a fan of Real Madrid instead of Barcelona, then he would not hate the fans of Real Madrid anymore, but instead he would hate all the fans of Barcelona, which would increase the number of pairs who hate each other. Yeah. So by moving it, you increase the number of pairs who hate each other. So in total, when you want to maximize the controversy, it's better if your two opposite groups, their size is as close to each other as possible, right? So this is the proof with intuition. This gives you the intuition. If you want to maximize the controversy between two types of people, it's better if their size is equal as much as possible. Okay. And this also gives you something else as well. If you now say that all the people from the same group, they love each other. For example, Real Madrid fans love Real Madrid fans, Barcelona fans love Barcelona fans. What is this? What is the number of pairs who love each other? What is the number of pairs who love each other? Not exactly. It's Real Madrid choose 2, X choose 2, plus Y choose 2. Yeah, X choose 2 plus Y choose 2. This gives us some observations. The first one is that obviously, if this is the number of pairs who love each other, X choose 2 plus Y choose 2, and X times Y, as I said, is the number of pairs who don't like each other, who hate each other. This gives us, this tells us that this is equal to n choose 2. Okay, so the first thing that is proved in here is that xy plus x choose 2 plus y choose 2 is always equal to n choose 2. Because this is all the pairs. If I say that in total, how many pairs do we have? The number of pairs is n choose 2. And I know that pairs are in two categories. The categories are that the first category is that the pairs who hate each other. The second one is the pairs who love each other. Okay, the number of pairs who hate each other is x, y. The number of pairs who love each other is x choose 2 plus y choose 2. So if you add these two values up, it's all the pairs. So it's equal to n choose 2. Right? Does it make sense? So the first thing that it gives us is this. And the second one is that if we want to maximize this value, x choose 2 plus y choose 2, the best thing if x and y are as far as possible. That also makes sense, because if all of the people are from the same group, then nobody hates the other one. All of them love each other. But as much as you split them into two equal groups, less people will love each other and more people will hate each other. Right? So that's the main point in here. Okay. Yeah, I'll do problem D soon as well. I just want to make sure everyone are okay. And there's also an algebraic proof, as I said, for example, if x times y is equal to, as I said, y is equal to x plus y is equal to n. So it's x times n minus x, which is, we have this value, x times n minus x. Right? What we can say about this one? Balancing was kind of weird. Yeah, the point is the hate will be maximized when you balance them as much as possible, and the love will be less. No, I'm saying that assume that x and y was closer to each other, then the number of pairs who hate each other was more, right? I'm saying that if they were closer to each other, the number of pairs who hate each other would be more. Okay, so x times n minus x is equal to nx minus x squared, right? So this is what we have. Well, again, we can say everything algebraically. We can say that if what happens if we add 1 to x. If we add 1 to x, we have x plus 1 times n minus x minus 1. This is gonna be nx minus x squared minus x plus n minus x minus 1, right? So this is gonna be this. And if you want to compare these two numbers and see that which one of them is greater than the other one, nx is the same, x squared is the same. So what we have is that when we add 1 to x, the total number will be added by n minus 2x minus 1. So it just shows that it's optimal to add 1 to x if x is less than n half. Otherwise it doesn't make sense. So it gives us that if x is less than n half, it's okay to increase x by 1. The effect is gonna be non-negative and even positive if it is n half minus 1, for example. So in here we can show that algebraically it just makes sense to increase x if x is less than n half. Okay, so this was the proof. Now we showed that as much as these two numbers are closer to each other, then the product is maximized. So we try to make them as close as possible to each other. Okay, so what do we say? We just say that, okay, one of them starts from the first digits. One of them, either both of them are equal. We will continue until both of them are equal. Both of the digits are equal. Then we can't do anything. Everything is the same. So they are okay. The first time that they are different, for example, we can have the smaller number above and the greatest number below. And then in order to make them as close as possible, the rest of the digits in here should be maximized and in here should be minimized. Because now we are sure that the number below is less than the number above. So what we can say is that when we are sure that this is less than the other one, it's better if we maximize this. So for all the digits after that, we try to maximize the one below the other. Okay. We can also derivative and make it 0. Yes, we can also do that, but that approach is more complex. And that gives you that the base case is exactly n half, even if you can also have double cases. Yes. So after the first digit, the one which is smaller should become bigger than the other. I mean, all the digits after that will be bigger. Okay, shall we move on to problem D? I hope that I know that it took a little bit of time to prove that these two are equal, but I thought it was good if I would explain it once. I hope that you enjoyed it and you learned something. I personally like this type of arguments, you know. Okay. Okay, so coming from washroom. Okay. Okay, so let's move on to the next problem. I need some time to read that as well. Yeah, so far problems seemed to be relatively easy, but I think always educational runs, the first three problems are like this, aren't them? Yeah. So, okay, I'm just reading the problem now. There are balls of n different colors. The number of balls of the ith color is ai. the balls can be combined into groups. Each group should contain at most 2 balls and no more than 1 ball of each color. Okay. Consider all 2 to the power of n set of colors. Okay, each color, did we have only 2 colors? The balls can combine into group. Each group should contain at most 2 balls and no more than 1 ball of each color. Consider all 2 to the power of n sets of colors. For a set of colors, let's denote its value as the minimum number of groups the balls of those colors can be distributed into. For example, if there are 3 colors, 3, 1, and 7 balls respectively, they can be combined into 7 groups and not less than 7. So the value of that set of colors is 7. Your task is to calculate sum of values over all 2 to the power of n possible sets of colors. Since the answer may be too large, print it modulo. Well, I think I have some problem reading aloud and also understand the problem at the same time. For a set of colors, let's denote its value as the minimum number of groups the balls of those colors can be distributed into. For example, if there are 3 colors with 3, 1, and 7 I see. They can be combined into 7 groups and not less than 7. What does it mean if that they can be combined into 7 groups? Because what I see in here is that 3 of them can be matched with these 3, and this one can be matched with one of these. So there are 4 pairs. As the minimum number of groups, the balls of those colors, the minimum number of groups. The minimum number of those groups, not the maximum number of pairs that we can make. Okay, I got it. So yes, 3 of these will be matched with 3 of these, 1 of these will be matched with this one, and the other 3 will be matched separately. So it's that 4 plus this other 3 alone balls. Yeah, gotcha. So, yeah. So do you know what is the answer? I mean, what is the number of groups? The number of groups, obviously, this is some sort of like classic, I mean, if you have several one of them, the number of groups is equal to minimum of, maximum of sum of all of the numbers divided by 2 and the maximum elements. Why? Because, if you consider the color that has occurred the maximum number of times, all of them should be in different groups. So we need at least that many groups. We need at least, if the maximum number is this max, then then we need at least these many groups, right? And we need at least sum of AI divided by 2 as well. Yeah, we can't group the same elements, but yes, divided by 2 is safe. Do you agree with this? Has anyone used this approach? I want to just make sure that I haven't misread the problem. I will explain why. If I haven't misread, I will explain why now. The point is, if we just want to match them 2 by 2, when we want to match them 2 by 2, right? Do you agree that we need at least these many groups? If you ask why is division by 2, I tell you why the answer is not more than this. Okay, use this approach, good. Okay. So, yeah, so this value is the sum of the numbers divided by 2 because we need at least many. For example, if we have 7 numbers, then we need 7 balls. Then we need at least, we know that each group has 2 balls. So we need at least 7 divided by 2 groups. Okay, so the answer is greater than or equal to this, which is 4. I mean, if we have 3 groups, each of them can cover 2 balls. Each of them can contain 2 balls. So we cannot have 7 balls in total. So this is the proof that we need at least this much, and this is the proof that we need at least this much as much as maximum is that because maximum, all of their balls of those colors need to be in different groups. So we need at least that many groups. Right? We need at least that many groups. So we need both of these. Now I just need to show that this is exactly equal to the answer. The answer is not more than this. Because maybe someone argues that yes, the answer is greater than or equal to this and also greater than or equal to this. But maybe it's greater than both of them. Right? I re-explained the first one. I'm saying that the sum of them is the number of balls. Okay, assume that we have 15 balls. I'm saying that if you have 15 balls, you're gonna need at least 15 divided by 2 groups. The sale of this, which is 8. Because if you have less than 8 groups, for example, you have 7 groups, each one of them can have only 2 balls. So in total, you're gonna have at most 14 balls, which is a contradiction. So you cannot contain 15 balls into 8 groups. Okay? So sum of AIs is the number of balls that we have. I'm saying that the number of groups is gonna be the sum of these AIs, the number of balls that we have divided by 2, the scaling of this. Okay? Yes. They can be from different colors. I'm just saying that the answer should be at least this much. I'm not saying that the answer is equal to this. I'm not saying that answer is equal to this. I'm saying that the answer is going to be greater than or equal to this. Greater than or equal to scaling of sum of AI divided by 2. It can never be. The answer can never be less than this. This is my argument. Do you agree with this? I'm saying that the answer is always greater than or equal to this. I'm not saying it is equal to this. Right? Also, I'm arguing that the answer should be greater than or equal to maximum number, maximum of AIs. And why? For example, assume that there is in here there is a ball that has occurred 10 times. We have 10 balls of color 1. Then do you agree that for each one of them we need another group, so we need at least 10 groups? So the point is the answer should be greater than or equal to, the number of groups that we need should be greater than or equal to sigma of AIs divided by 2, the scaling of it, and it should also be greater than or equal to the maximum. Okay? So it should be greater than or equal to both of this. Now I want to show that it doesn't need to be greater, it doesn't have any additional constraint. So it is exactly equal to maximum of these two. If it is the smallest number, the smallest x, such that x is both greater than or equal to this and greater than or equal to this. There's no additional constraint for x. Okay. So x should be greater than or equal to sigma of AIs divided by 2, and x should be greater than or equal to max. And why, by induction, you can show that, well, there are two cases. The first case is that if max, let me write on a blank board. The first case is that if max, first let me tell you the easier case. If max is greater than n divided by 2, n is the total number of balls. N is equal to sigma of ai. If max is greater than n half, then obviously all of them should be in different groups. And therefore, and the rest of them, because are less than max, the rest of them is n minus max, which is less than n half. So the rest of them can come here as well. So if max is greater than n half, or even greater or equal to n half, we can say that the answer is definitely max. Do you agree? I mean, if by max I mean the color that has appeared the maximum number of times. Okay, so the first case, I want to show that the answer is maximum of the sum of numbers divided by 2 and max. So I want to show that the answer is gonna be maximum of these two values, n half and this maximum occurrences. First, I showed that if max is the maximum one, then definitely that one is the answer, right? The second case is that the second case is more challenging, is that if max is less than n half, less than or equal to n half, then I want to show that you can have all the balls in n half groups. I mean, by n half I mean the sailing of n half. If this happens, I mean the case that they are equal, both of them work. I mean, because they are equal, both of them are the answer. So if max is at most n half, you can show it with induction. Okay, you can show that the answer is yes with induction. Well, you can say that consider the two maximum balls. The two balls that you have the maximum. You know that none of them are greater than n half. None of the numbers are greater than n half. Assume that the first two colors, the two colors that you have the maximum number of them. If you match one of the balls from here and one of the balls from here, for example, assume that your numbers are like this. Your A1 is like 4, your A2 is, for example, 2, 3, and 5. Then all the numbers are less than or equal to n half. Okay, what is n in here? Your n is 8 plus 6 is 40. So n is 40 in this case. 14. Okay. All of the numbers are less than 7. Less than or equal to 7. I'm saying that if you consider the two maximum numbers and match one of the balls from here and one of the balls from here, so you will subtract, after that you will subtract one from this and one from this, because they are now one group and they're out, they are just one group, and the others are remain. Well, I show that then after that, still the condition will be there. I mean, the condition is still hold. And therefore, using induction, we can say that the rest of them can be solved too. Why? Because when you decrease the two maximums by 1, there are two cases. Either these elements are greater than the new n half. The new n half is the previous n half minus 1. N is decreased by 2, so n half is decreased by 1, right? But these numbers, we know that they were at most n half, the sailing of n half. So now that they are decreased by 1, they are still less than or equal to n half minus 1, sailing of n half minus 1, right? So, yes, I will also do the complete pairing too. Yeah. So these are okay. These are still okay. These still holds the conditions for our induction. And the third number cannot be greater than n half minus 1. Why? Because it means that it was initially n half because it hasn't changed. If it is greater than n half minus 1 and it wasn't greater than or equal to n half, it means that from the beginning it was n half. And because these two numbers were the maximum numbers, they need to be at least n half 2. This shows that we have at least 3 n halves. And since n is positive, 3 times n half is greater than n, which is a contradiction. This means that only the balls from these colors is more than the total number of balls. Okay? So I'm saying that when you choose two maximums and you remove them, you see that here your new n is gonna be 12. So your new n half is gonna be 6. I wanna show that no number will be greater than 6. Why? Because I know that these two numbers were not greater than 7 and now they are subtracted by 1. So they are not greater than 6. And I know that the third number, the third maximum is not greater than 6 as well. Because if it was greater than 6 and it was not greater than 7, it means that initially it was 7. And these two maximums should be at least that much as well. So these two should be at least 7 as well. So we need at least 3 n halves. We need at least 3 sevens, which is obviously greater than n because n is positive. 2 times n half, 2 times, let me write here, 2 times sale of n half is greater than or equal to n itself. When you add an additional n half to it, because n is positive and it is sailing, it would definitely be strictly greater than n. So this shows that after each operation, still nothing would be problematic. So if I want to do the complete case here, so if I want to complete it, the next step I have to change these two. For example, these are maximums. This 3 is equal to this 3, so I can change either one. I change this one, for example. So this becomes 3, this becomes 2. The next one, this becomes 2, this becomes 2. The next time, this becomes 1, this becomes 1. Next time, this becomes 1, this becomes 1. Next time, this becomes 0, this becomes 0. Next time, this becomes 0, this becomes 0. So you see that I could match all the pairs. So I'm saying that if none of them is dominating, if none of the colors is dominating, it is more than half of the whole array, then for sure I can match all of them without worrying about that the same colors cannot be in the same groups. Okay, this is a classic idea that really helps you to solve this problem. Okay, so this is the first thing that I'm talking about. That's the answer is definitely gonna be maximum of n half and the maximum occurrence of a number. Some more public Moore algorithm. Well, I'm not sure what public Moore algorithm is. Yeah, that's a good question. How did you come up with this so fast? Well, as I said, this is somehow classic and like I've seen this before. I've seen such things before, and from now on you have seen this before too. So the next time that you see this, you have seen this before. So the point is, when you want to match pairs, and these pairs should be each one of them, their class should be different or their color should be different, what you can say is that the answer is always maximum of n half and the maximum occurrence of a number. This is very classic and you see it in many problems. If you want, maybe in future I can solve more problems from this idea. This is a well-known idea. Oh, no. I see what you're talking about. No, it's not like that. It's not like that. Yeah, I know what you're talking about, that you have a CNT and when you see it, that number again, you increase CNT by 1. Otherwise, you decrease it and change the number if you want. That is a very very interesting problem. But no, in here, uh, in here is not very much. It is somehow similar, that because we're saying that none of them are greater than n half. But I'm saying that in here the whole point, the most important point in here is that none of them is strong enough to make an issue. None of the colors, we have that many of that color, that makes problem for us, cause problems for us, because for any of them, all of them are weak. So there's not one of them is the majority, and therefore because we have a majority of them, then we cannot match them with others. Every color is, none of the colors dominates, so it is okay, we have enough other colors for them so that they can be matched with others. Yeah, I will. Sure. Okay, has anyone got this? Yeah, this is a well-known idea that once I saw this problem, I figured that out because this was in my mind. I knew this from before, and I hope that next time you see a problem, just when you read the problem, you remind this and the reason behind it, not just memorizing it. That know the reason behind it, why they can be matched. So if it is okay, I can just say that, let's see, I can just say that in here, for all 2 to the power of n sets of colors, I want to find this number. Okay, so the main thing is that we want to find this out for all the sets of colors, right? So this is when it gets more interesting. And in here, n is up to 5,000 and ai's are up to 5,000. The total number of balls does not exceed 5,000. So we have at most 5,000 balls. Okay, so there's a DP, it's a DP. So you just store what is the total number of balls and what is the current maximum, I think. Yes. I think it makes sense. Yep. You have some balls, each one of them, you can arrange all the balls. You can arrange all the balls right after each other, and each one of them have a color. You add them one by one. I mean, there are 2 cases. When you're talking about a new color, let's process all the new colors at once. When these are from color X, okay. Either you have this X, I mean, you're gonna, in your subsets, you choose X, or you do not choose X. If you do not choose X, it doesn't change anything. But if you choose X, it changed sum and maximum. Okay, so if previously I was in the states I and J, now I will go to the states I plus X and maximum of J and X. Because now my sum, if my sum was I and my maximum was J, now my sum is I plus X and my J is maximum of J and X, right? So yeah, it's mostly about being able to update this so that it's within the squares in total, not no, it's not 2 to the power of n. We have dp. If we do it very trivially, it's gonna be n cubed, but I'm thinking about not doing it very trivially. Yeah, I will. Which part did you understand? I'm just saying that between all subsets all of these 2 to the power of n subsets, we have to find the maximum of them and the sum of them divided by 2. So we need to have some maximum of sum divided by 2 and maximum. I show it with mx. Okay. So I'm saying that for each subset you have to you have to add maximum of sum divided by 2 and mx, right? I'm trying to do that for each subset. I find that you can iterate, introduce one color at a time, and store number of subsets of size I. Subsets of size I. How do you keep the maximum? I think we don't need to keep the maximum. We can just source the array at the beginning. And if yes, it doesn't make, yeah, I think we can just source the array initially. Let's just sort. Do you agree that nothing changed if we source it initially? I mean, their order doesn't matter. They are just the number of balls. So their order doesn't matter. Do you agree with this? So the order doesn't matter. So we can have in them in a sorted way. Why I did that? Because when I source them, when I add a new color, when I introduce a new color, then this new color is definitely the maximum. It's not possible that the previous ones were maximum, and we don't really need to be worried about storing the maximum. You see what I'm talking about? So I'm saying that I'm sorting it because I want to make sure that when I add another color, I'll be sure that the maximum is this one and not the previous one. And this way I don't need to store the maximum, right? So yeah, we sort them and we just have some dp of I and j that gives us what is the number of subsets such that their last color is color number I, their last color is color number I. This is, for example, dp1. dp2 is that the last color is at most color number I. I mean, they are from the first I colors. Okay, I'm just explaining it. You can maybe implement it at the end. We can simplify this, but I'm just saying that first, assume that we have these two dp's. dp1 of I and j means that the last color that we chose is AI. We haven't chosen anything after AI, and AI is chosen. dp2 of I and j means that the last one is less than or equal to color I. I mean, it is all from the first I's, but it's not definitely that I comes as well. So when you want to add color number I plus 1, let me go to whiteboards. When you add color I plus 1, as I said, we have some, as I said, we have some dp1 of I and j and dp2 of I and j. When I add I plus 1, I have to consider dp2 of I and everything, because it means that all the subsets that are completely in the elements before I plus 1. And I can see their size. And I see that what happens when I add this one. I know what happens to sum. Sum will be added by a of a plus 1. And I should say that dp1 of I and j will be added by, in dp1 of I and j, I know that I can compare a of I plus 1 and j divided by 2, this new j divided by 2. And it's enough to only just compare this last one. I don't need to store that, save that what was the maximum so far. Okay. J means you only use elements up to J, I think. No, J for me J was the size of the I mean the number of balls that I have in my subsets. The number of balls, the total number of balls. Okay, so J is the sum. J is exactly the sum. And I is the prefix of the balls. Okay. Yeah. So I said that in DP2, for example, I store that how many ways do I have for them for the first I balls such that their sum is equal to J, is exactly equal to J, such that their sum is exactly equal to J, right? I can do that, and well, afterward, I can just say that I see that how many of them exist, and I see that when I add this I plus 1, what happens to them? Is their number of balls now maximum? The number of balls J divided by 2 is the maximum, or A of I plus 1 is maximum? And for any of those cases, I should multiply these two numbers. I mean the number of only this dp, as I said, we can also remove the other dp. Only this dp is enough. Dp of I and j is the number of ways such that from the first I numbers we have chose some such that their sum is equal to j. Only this dp is enough. I can say that when I add I plus 1, I can just see that how many of these sets exist, how many of these subsets exist, and then when I add I plus 1, I know what is the new j. I should add just I plus 1 to it, and I know what is maximum. It's a of I plus 1. And then I can say that I compare j divided by 2, j half, and a of I plus 1, and the maximum one of them is going to be my answer. Okay, yeah, I is only elements up to I, yeah, the first I elements. Yes, the number of subsets where I is considered, where the first I elements are considered. Some of them are in our subsets. Okay, some of them are in the subset, and maybe none of them are in our subset, but some of them there's no additional constraint. Some of them are in the, it's like we only consider the first I elements, the first eyeballs, and then not the rest of them. Okay, so dp of I and j is the number of ways. So when I add I plus 1, I have to update dp of I plus 1 and j plus a of I plus 1. You know, the beauty of it is here. We don't need to store the new maximum because this number is less than the next numbers. We don't need to store the maximum anymore, right? Yeah, I is included, yeah. No. But what do you mean? I is included in my dp dimensions, I meant, but not that in our subset I is always there. I is always included in our subset. As I said, maybe no element is in our subset. I'm just saying that we are considering the first I elements, and some of them come. No additional constraints. Maybe the last one does not come. Maybe none of them come. Okay. So does it make sense? I have this dp, and the beauty of the idea of sorting was that I do not really need to store the maximum, save the maximum anymore. Okay. The space complexity is 5000 times 5000 because j, the sum, is at most 5000. It said that the total number of balls doesn't exceed 5000. So j is at most 5000 and n is up to 5000 as well. So this is n times sum, both of them up to 5000, which is okay. Okay. So that was the main idea for problem D. If you are completely okay with that, we can move on to problem E. Otherwise, we can talk more about this one. Yeah, that's true. We can also just think about the row that we are looking at, but because the constraints are low, that's okay. Yeah, I see that. That's an issue that you don't see the constraints. It sometimes happens to me as well that I don't focus on constraints, but anyways, yeah. What will be the formula for dp of I and j? dp of I and j is that if we only consider colors 1, 2, 3 to I, and we just have a subset of them, so are from our colors are from, for example, 1 to n, 1 to I, sorry, 1 to I, let me write here, 1 to I, and a subset of them is chosen, okay? And dp of I and j shows that in how many ways I can choose a subset of them such that the sum of the number of balls, such that the sum of those ai's is gonna be exactly equal to j. Okay, so dp of I and j just tells us that what is the sum uh, of the a's of that subset. How do we count them? Using dp. I'm saying that when I plus 1 is introduced, I can just go to dp of I plus 1 and j plus ai. So dp of I and j, a of I plus 1. dp of I and j goes to dp of I plus 1 and j plus a of I plus 1. Because this is a knapsack problem, how to calculate dp. Okay, this is completely a knapsack problem. dp of I plus 1 and j plus a of I plus 1 will be added by dp of I and j. Okay. So this is a simple knapsack problem, that how do we calculate dp's. When we add j plus 1, all the elements with value, when we add I plus 1, we can also add a of I plus 1 to all the j's. So dp of I plus 1 and j plus a of I plus 1 will be added by dp of I and j. I hope it makes sense. Does it make sense? What about the rest of you? Do you need more explanation on this problem? If you don't, we can move on to the next one if you want. Okay. So let's move on to the next one. I'm not sure if we can solve it in the class today. I mean, in the stream today. Let me see how people did this problem. Many people did it very fast. So yes, I want to discuss E And about D, you mean write code for D? Yeah. Guys, about the problem D, I again recommend you to uh, try to read about knapsack problem first. First, you need to read knapsack problem. DPs are completely knapsack problem. Okay, maybe you can read it from Wikipedia. Read about knapsack problem, and that gives you some insights about everything. And then the DP in this problem is gonna be very easy. Yeah, AdCoder DP contest is very good. Let me also send you the link of AdCoder DP contest in my phone. Let me send it. AdCoder DP contest. It has a lot of good DP problems, and some of them are also classic ones, like knapsack. Yep. So yes, that DP problem that I was talking about was knapsack. So anyways, you can do this. You can do this AdCoder educational DP round. We also grab maximum. Yep. Yes. Yeah. When we do transition, we also grab maximum of j divided by 2 and j divided by 2 and a of I plus 1. And yes, both of them, the maximum of these two will be multiplied by dp of I and j. Can you make video series on knapsack with your dp widths? Yes, definitely. How to move from newbie to expert? You really need to go to problem sets, as I said before. Let me just say it very fast. And source the problems in here by their difficulty, starting from the smallest difficulty to the larger ones, the greater difficulties, and then start solving a lot of problems. You know, if you see in here, some of them is not solved for me, it's because they are the new problems. But when I was doing training, almost all of these were green. I mean, the first page were almost all green. It is changed a little bit now, but at the time it was almost all green. Right? So I recommend you to solve a lot of problems, starting from the easiest ones. Okay, so what is problem E? No one has solved problem E, right? No one who is watching right now. Yeah, I see. Yeah, lead code is not as good as Codeforces for competitive programming. Yeah. For competitive programming, you should focus more on Codeforces. Let's see. Yeah. Okay. So let's talk about problem E. There are n monsters standing in a row. The monster number I has AI health points. Every second you can choose one alive monster and launch a chain lightning at it. The lightning deals K damage to it. When the lightning reaches a dead monster or the beginning end of the row, it stops. A monster is considered alive if its health points are strictly greater than 0. For example, consider the following scenario. There are 3 monsters with health equal to 5 to 7 and k equal to 3. You can kill them all in 4 seconds. Launch a chain lightning at the third monster, then their health values are... Let me see why. Okay is equal to 3. Launch a chain lightning at first monster, and their values are... Okay. For each k from 1 to maximum of a1 to an, calculate the minimum number of seconds it takes to kill all the monsters. Dealing k damage when the lightning reaches the dead. And also spreads to the left and to the right to alive monsters. Okay, I see. Yep. Yeah, I see. Okay. So, yeah, maybe we can think a little bit on it. Starting from beginning. Well, between two neighbors, the first fact that comes to my mind is that between each two neighbors, the one which has less health level compared to the other one, the one which has the lesser weights health level will die sooner. For example, if the health of this one is 3, the health of this one is 5, this one will definitely die sooner or not later than the other one. Right? Yeah. Yeah. It splits them into two disjoints problems. Yeah. Yes. And then still... Okay, definitely initially the minimum one dies as the first one. You can say that how many times? Yeah, the way they die is kind of clear, straightforward, right? The way they die is kind of straightforward. If you consider the minimum, right? Yeah, okay. If you consider the minimum, this is the first one that dies, and you can see that when you have some k, you have the sale of this number. Your minimum, for example, is a of m divided by k. These many times this should be chosen. Okay, this many times these elements should be decreased. I mean all of the elements will be decreased by k. And then the rest of it will be splitted into different parts. Okay? And then the same thing happens in all of the subsegments. The minimum will be chosen and it will go like that. And in here, n is up to 10 to the power of 5 and ai's are up to 10 to the power of 5, 10 to the 5th, which is an interesting thing. Well, that might sound reasonable. Doing that might sound reasonable. I'm not sure about it. Maybe I can take a look. Maybe we can think more on it. But if we want to save a little bit time, maybe I can, if codes are public now, maybe we can take a look at some code so that I can explain it. It's small. Int of a, scene a, if p. Let me see what it's talking about. Okay, so p is the previous one. K is the maximum. P is the previous one. And if this one is greater than previous one, I most of p plus plus, I most of a minus minus. It's interesting. It's getting really interesting. Just let me see something. Why for each k from 1 to maximum of a1 to an? Can't it be more than the maximum? I mean, for example, yeah. Oh, k is from 1 to maximum. Sorry, I thought, yeah, that's okay. K is from 1 to maximum. That's the number of steps. I most of p plus plus, I most of a minus minus, p equal to a, k is equal to maximum of k and a. What do you think IMOS is standing for? Well, in here, IMOS is even either is some number that is either 0 or is, I mean, it's small. It's at most. Yes, it is something from -1 to 1. It seems either 0 or -1 or 1. If p is less than a, IMOS of O. So you know how many okay. It's oh, I think I'm getting some insights. If p is less than a, I think I'm getting it. Just, you can also think about it at the same time. If you see the code, you can think about how does it. Initially when I started competitive programming, this was what I was doing. I was reading codes and I was trying to find out what it is doing. So maybe you can do it at the same time too if someone understands what it is doing. But I think I'm getting it. I'm getting clue about it. When you have Well, that P and A are standing for this. We have this, this P is some number, this A is also some number. Okay, so we have this P and we have this A. Okay, so they are two consecutive numbers. What this code is saying is that between these two numbers, if you consider between these two numbers, the point is when you subtract numbers by k, they don't change modulo k. Okay, they won't change modulo k. Okay, they are always some sort of like a minus x times k. You know what I'm talking about? They are a minus x times k, for example, right? So it is always minus x something, x times k or something. Well, the point is, if between these two numbers, if there is no multiple of k, if there is no multiple of k between these two numbers, then that means that these two monsters will die at the same time. I'm saying that if, for example, this is one multiple of k, this is, for example, 5 times k, and this is 6 times k. We know that what is k, and these two are between 5 times k and 6 times k. Okay? I'm saying that these two monsters die together. After, they die exactly at the same time. Okay? Do you agree with this? So the first thing that I'm saying is that if the half of this one is P, this one is A, and A is more than P, then obviously this was a very beautiful problem. I really loved the solution. If this is 5k, this is 6k, then definitely these two will die at the same time. So if for each interval, each time we choose an interval and subtract k from all of them, each time we choose an interval and subtract k from all of them. Okay. So if we say that from which monster it starts, from which of these monsters this interval starts. Okay. If we consider this, what I can say is that none of our intervals starts from A. Because if for each interval we consider that, okay, it starts, if you want to start from somewhere and it is spreads to the left and to the right, we can start from the leftmost one and it only spreads to the right. We can always do our operation on the leftmost one, right? We can always do our operation on the leftmost one. So I'm saying that if this happens, A has no effect on the answer. That it never starts another interval. It is just there, and whenever P dies, it dies as well. A dies as well. Whenever P dies, A dies as well. So there's nothing to be worried about A, right? So this is what we're talking about in here. Okay, the first thing is this. So the point is, if A is here and they are both between two multiples of k, then A has no effect on the answer, because it never starts another interval. If we assume that each interval is started at its leftmost cell. Is everything clear so far? If everything is clear, just put a plus in the chats. If everything is clear so far, just put a plus so that I can continue. Okay. So now what I'm saying is that now assume that there is one multiple of k between these two. For example, this is 7k. And there's 6k is something in middle in here. Okay, my battery is dying as well. So 6k is between these two. Now I'm saying that one additional interval should be started at A. Because whenever P dies, A should start another interval. So A is always with P, but after P dies, A needs one additional step. So A will have one additional step too. So A will add one interval. A will start another interval itself. Is it clear? So I'm saying that as many as multiples of K are here, it means that A, for example, if there are 3 multiples of K, it means that there should be, we should start 3 intervals from A. Okay, so that's the whole point. If there are 3 multiples of K between A and P, then let me just make the example more clear. So for example, this is 5K, this is for example 6K, this is 7K, 8K, 9K, 10K. So what I'm saying is that if there are 3 of them, we should start 3 new intervals from A. Now, what I can say is that in here he's trying to use prefix sums. He's trying to say that a multiple of K should lie between these 2 numbers. Okay, so a multiple of K should be less than A. Yes, a multiple of K should be less than A and greater than or equal to P. I mean, it should be exactly in this interval. A multiple of K should be greater than or equal to P and less than A, some xk. So we want to count this for any 2 consecutive numbers, and for each K, we want to see that what is the sum of these numbers. We want to see that if for each 2 consecutive number we sum up these values, what is going to be the answer. What do we do is that we use prefix sums. We use prefix sums, we add P and we subtract 1 from A, and then we update these prefix sums. And for each K, we just need to do this. You know, the point is, I start from 0, and initially P is 0, because I can assume that there are 2 monsters at the beginning and at the end, and both of them have health 0. So that we can also consider all the intervals starting at the first monster, from the first monster. So I start from 0, and each time I add K to I. Each time I add K to I, and I say that I consider 0, K, 2K, 3K, and so on. If you see in here, the effect of each of these intervals starts from P and ends at A. So all the numbers in these parts will be increased by 1. So I want to see that how many multiples of K are in these intervals. Well, I know this by prefix sums, that some number x is in how many intervals? I mean, I have several P to A intervals. For each number, I know that in how many of them it exists. So if only for multiples of K, I see that in how many of these intervals these multiples exist, I know that what is the sum of these values. And I can just print that as our answer. That's the whole point. I want that for each interval from P to A, how many multiples of K exist. Well, what I do, I say that for each multiple of K, I just see that how many intervals from P to A exist such that this multiple lies into that interval. And what I can do is that, okay, I have prefix sum and I know that for each I, in how many of those intervals I is. I can do that with prefix sums. Then I have a for on multiples of I, and I can just add those values up, and that's going to be my final answer. Does this make sense? Is it completely okay? Did you understood it completely? Have you understood it completely or not? Do you have any questions about this problem? So that's all about this problem. If you have any question about this problem, you might ask. This was very beautiful. This was a very beautiful solution. I really liked it. I really liked it. I wish I had a chance to think about this problem too. But we had a limited time. But it was really interesting. This solution was really interesting. Yep. You know, for example, when k is 2, when k is, for example, 3, and we have two numbers like 5 and 13, for example. There are two consecutive monsters. The first one is 5, the second one is 13. I want to see that how many intervals I should start from 13. I know that each interval is each one of them is an interval, and I want to see that I calculate each interval in its leftmost cell. Okay, so what I say in here is that I can just understand that how many multiples of 3 is between 5 and 13. The multiples are 6, 9, and 12. So what I argue is that I have to start 3 intervals from 13. I have to start 3 intervals from 13. Why? Because 13 will be increased with 5. They are adjacent. They will be decreased with each other. After the first time, this becomes 3, this becomes 10. So 13 does not do anything. It goes down with a 5. This one, becomes 2. It goes down with 5. And the next time this one becomes -1, this one becomes 7. And the point is, when it is 7, you still need 3 more operation at this one, but its previous monster is dead. So you have to start these 3 operations from this one. So the point is, when you have some multiple of 3 between 5 and 13, because all the numbers modulo 3 will not change, when this number becomes less than 0, still there are some multiples of 3 less than the final number. In here, this became 6, 0, 3, 6. They became this. So still there are 3 multiples. There are 3 barriers that it should pass. So the whole point is that still you need at least 3 operations for it. So the whole point is that when you start an interval from its leftmost elements, the whole point is that the number of times that you should pick that element, that monster, start from that monster, is equal to the number of multiples of k between these 2 consecutive numbers. The integer overflow. This also happened to me before. How do I stop doing stupid mistakes? Again, solve a lot of problems and participating in a lot of contests. You have to learn it in the hard way. You have to do the mistake many times and feel bad about it until you finally, it comes into your mind that you shouldn't do this mistake. And it becomes more rare over time. It never becomes 0. I still make bugs. All of us, when for example, a few months, we don't write codes a lot. When we start coding again, we have some bugs in our codes, and that's completely okay. So it never becomes 0, but as much as you participate in more contests, write more solutions and more codes, this becomes better. Okay. Guys, did you understand the solution of this problem? You have this P, you have this A. The number of times that you have to choose this monster is equal to the number of multiples of k between these 2. I want to know how you can improve your CPU skill from blue to red. Just do a lot of problems and try to understand some nice code. Well, trying to understand some nice code is a great way that it really helps me. After experts, well, have you guys watched Omnic's interview? My interview with Omnic. He talks a lot about this as well, about his own opinion. Omnic is the legendary grandmaster in Codeforces. He was once at rank 1 in Codeforces, and also he won ICPC. So, well, he says that try to, and this is what I was saying in my streams as well. He also mentioned that you have to just solve the problems, and whenever you reach a problem that needs some algorithm, you can just then learn that algorithm. I mean, I don't recommend people to go start just learning algorithms from books. The whole point is problem solving. I'm not saying that never do that. Yes, sometimes you need to learn new algorithms, but first make sure that your priority is in solving problems. Okay, so focus on solving more problems rather than anything else. And yes, once in a while you should learn new algorithms, but I recommend that between each two algorithms that you learn, there can be, for example, even a month gap. So I think maybe once in 3 weeks or once in a month you should learn a new algorithm. But in the meantime, after you learn it, you should train it, and you should find out a way. You should train it, and you should be able to solve the problems and get accepts from them. Okay. One of you asked the question about problem E. What if we have a number bigger than the previous element? If the previous element is greater than the next one, then it is okay. Whenever it dies, this one dies as well. Whenever the previous one is dead, this one is dead as well. So you can leave it. You can leave it. It's just it doesn't have any effect. You can leave it. And we said that we only consider the leftmost monster each time. We consider the leftmost monster and we do the operation on that one. I'm saying that if someone is less than its previous one, you never start something from it. You start from previous ones and it dies with its previous one. Okay. Is it clear? Can you suggest some problems that I'm master and striving to be right? I recommend you to make a list in Codeforces out of people that you think they're good. For example, I did this in my country, and I knew some people who have solved a lot of people. I made a list in Codeforces, and whenever I was choosing, it was showing in front of each problem that how many people have solved that problem. And most of times the problems that many people have solved them were very beautiful problems, very good problems. And I solved a lot of those, and that was a very good approach. And also, yes, I have problems. I try to share more problems in our Discord server so that everyone can use. And again, guys, everyone, I recommend you to watch the DP series. That might really help you. I think DP is the most important one, and I'm trying to solve problems from different difficulties. No, as of now, I have 1500 plus problems and 2000 plus difficulty problems. I wanna also solve 2500 plus problems. That is gonna be very helpful for people who wanna reach reds too. Yeah. I guess my battery is close to die. So if you have any other question you might ask. I have started CB. I am unable to think for the solutions. What should I do for it? Well, the main thing, again, as I mentioned many times, the main thing, it's very clear. Just keep practicing, solve a lot of problems. Many people ask this, and it has a very simple answer, but implementing it is hard. I mean, you have to solve a lot of problems in Codeforces. You have to sort the problems, start from the lower difficulties, and solve a lot of them whenever you need to read the codes of other people, trying to understand them, implement them, etc. So that's the main thing that you have to do. And this is very simple, but implementing it, doing it, actually doing it might be a little bit hard. So no. Codeforces has list feature. You know, let me show it. When you go to Codeforces to your problem sets, what is your age and where do you work currently? Yeah, I answer this in my every stream. I'm 23 and I'm currently in the United States. I'm a PhD student. This is the lists, user lists. In here, when you say this, you have made some lists and you can choose them. It doesn't work anymore. So you can choose them, and you can choose them. For example, this one. And then it tells you that for each problem, how many people from that list have solved them. For example, you see that 15 solved out of 15 who tried. And the ones that many people have solved, for example, let me search for a problem at 2500 difficulty. Or not 2500, 2000. Okay. I just can say, I also sort it so that with same difficulty, the ones with more solved will be first. And then I choose one of my lists. And after that, when it is loaded, in front of each problem, it shows me that how many people have solved that problem. For example, I see that this is 33 from 34. But when it is 33, it is a good thing. It means that a lot of people have solved this problem. So there is something behind this problem that maybe this is a famous problem, that a lot of problem have heard of it. People recommended each other to solve this problem, or things like that. Or this one is 39 out of 40, and so on. So you can make a list and just try to, and because I made this list years before, you see that most of the problems that have a lot of solutions are older. But you have to make a new list with new people and just see that how many of them have solved the problems. And in order to make it, I think, you should come to your profile and then lists and create new list, and you name it, and then you add people to it. You have to create it first. You have to create a list first. Yep. When your rating is 1200, I recommend you to solve problems with difficulty 1000 to 1200. Yep. Yeah, guys. I hope that you enjoyed this live stream. If you liked it, I think it might help if you like this video or my other videos and watch them completely. I also invite you to watch Omnic's interview again on the other channel. You can find that out in this channel as well. Many good things have been said in that interview. So I hope to talk with you very soon. We will talk very soon, and I will definitely answer more questions from you. So I think I'll see you next time. Yeah, you can see it in my accounts. I think a few months. A few months. And if you want, you can tell me your feedback about this live stream in the comments below. That would definitely help us. Thank you. Thank you for watching. See you very soon. Goodbye.